Okay. Also try to define the f function directly. And you will get a force on the f function, which is a path of the modern function theory. Unfortunately, his lecture was not published soon. I think it's quite later, 1870 or something. But Brio and wrote a book on empty functions, and it published 1859. So this is the first book written on elliptic functions based on the function theory, not the elliptic integrals. And later, Weierstrass gives a course on elliptic function theory in Berlin University, and it was so beautifully done. So today, usually we follow the Weierstrass approach. I think he did around the 1870s or 80s. So what they want to do is, you want to find some function f, which is a function on the complex plane, such that it has two independent periods. Okay, m and n are integers. And what kind of the condition you have to pose? So Liouville started. No, before, sorry. Then I said that we have an independent period. What does it mean, independent? So first of all, independent means that omega 2 over omega 1 is not in rational number. Because if it were rational number, then of course k omega 2 minus L omega 1 equals 0, or equal. So k times omega 2 is L times omega 1, so you can easily see that this will not be independent in a sense.
Omega 2, omega 1 is a complex number of
Yeah, certain complex number. Okay, that's okay. But then already Jacobi observed that if omega 1, omega 2 is real numbers, so ratio is real numbers, then you cannot get such a nice function. F should be, only possibility is, not 0, constant. Why? Z to W, where W is, I think, related to omega 1. That's correct? No. Yes. So that means that W is Z omega 1. Yes. Then this condition. So I write W is F of omega 1 Z. Then you can write that omega plus m plus n omega 2 omega 1 equals g omega. you can rewrite in this way. Just change the value. Therefore, I'm interested in the all numbers given by this m and n. Okay? And assume that it is not rational number, but it's real. What happens? Probably found it, and probably any positive epsilon, smaller one is better, so that you can find m prime and n prime integer such that m prime plus n prime omega 2 omega 1 is absolute values epsilon. But so this is a very good exercise, so please try. If you have a irrational number, and then m plus n times irrational number, you can find. So that means some numbers kn, ln of omega 2 omega 1, guess I should say an, and kn and ln is integer such that n tends to 0. So just integral linear combination of 1 and omega 2 over omega 1, we can find the 0 as a limit point. And then what do you know? You know that your value z plus an is always same. Of course, it's by assumption. So in particular, fan is f0. And then just look. Your complex plane. We are assuming that fz is holomorphic. Near, in the neighborhood of 0. Okay. And there you have some point set. You know, an plus 1 and so on. It converges to the origin. And there, fz has the same value. Then what can you say about that? If you have a function, holomorphic function, and you can find some point set which converges to some fixed point, some point, such that all value of sequence is the same. Then you conclude that fz is constant. Why? This is also a strong property of the holomorphic functions. I think I didn't prove it, but it comes from also that kind of the, what is the best way to prove? I think the best way to prove is I give a not correct proof, but the rough idea is just use the Taylor expansion. So you have a Taylor expansion here. So F0 is this. So you have A0 plus vector term. Oh, I don't know yet which way. And just consider the F of AN. Then this is A0 is again same as AN of K. This is equal A0. So that means that this part should be equal 0. And you have a infinite many AN. And you guess that all AK should be 0. Otherwise, there has to be a certain number. It's not a correct proof, but you can roughly you can guess. What is the correct proof? Yeah, correct proof is almost the same, I think. So just you compare in general FAN and FZ, and actually the best way to show is using this data. We can show that all derivative of 0 is 0 if n is equal to 1. Using this data, it's the same thing that this proves that this coefficient is 0. Yeah, because first of all, f prime 0 becomes 0 because if you choose an, this should be. Yeah? But this is 0 always. So this is 0. And then you consider the f prime z. And using a similar consideration, actually, you can show that you need to show that f prime an is also again the same as f prime a0. That's also you need to prove it using this. But then once you prove this, then you can use similar argument. So that gives you. So this gives you a very strong indication about that. Therefore, what Jacobi found is you should omega no, if you have a two independent in the period, then the ratio should be complex, really complex number, not a real number. Therefore, we may assume imaginary part of omega 2, omega 1 is positive. Yeah? Why? If this is negative, then just change it. You can easily show that inverse is positive. Yeah, this is also the typical property of the complex numbers. Therefore, instead of omega 1 and omega 2, just changing the variable, okay? So again, we may assume our period is, basic period is 1 and tau, where tau is complex number, it's imaginary part is positive. Therefore, want to find a function such that g plus m plus n tau is fz.